Welcome to this presentation. The question today is about turning effect of force. A uniform plank of wood weighing 50 newtons and of length 5 meters is suspended by two ropes A and B, 1.5 meters apart. A is 2 meters from one end and B is 1.5 meters from the other end, as shown below. So A is 2 meters from this end, B is 1.5 meters from this end, and both are 1.5 meters apart. A concrete block of weight 100 newtons is suspended from the center of the plank, and therefore calculate the tension T on the rope B. We are told that the 100 newtons weight is suspended at the center, so the center is 2.5 meters since the length of the plank is 5 meters. Another thing we need to take note of before we continue answering the question is that since the plank of wood is a uniform one, then that will imply that the center of gravity is right at the center of the plank, and for that reason the weight will have to act at the center, that is at point 2.5 meters, and we're told that its weight is 50 newtons, and therefore we have 50 newtons acting at this particular point, which happens to coincide with weight 100 newtons. Now, because we're required to get the tension on rope B, we will take moments about rope A. So we'll consider rope A as our turning point. Taking moments about A, that is rope A, we'll therefore apply the principle of moments, which states that at equilibrium, the sum of clockwise moments should be equal to the sum of anti-clockwise moments. That is about this point here as the turning point. We are going to begin with the sum of clockwise moments, and let us identify the forces that will cause clockwise moments. That is, if we consider A as our turning point. Of course, we'll have the 50 newtons weight and the 100 newtons weight, which will make the plank to dip to the right, that is for clockwise turn. We're going to get the sum of the moments. Let's begin with the moment as a result of 100 newtons. We'll have 100 times 0.5. So 0.5 is the perpendicular distance between the line of action of the force 100 newtons and the pivot. That is this distance here, 0.5. So if you multiply 100 newtons by 0.5, that will give us the moment as a result of 100 newtons. So that is for this part. And then the next one, we have moment as a result of 50 newtons. We'll have 50 times the perpendicular distance again, which remains to be 0.5 meters. Remember, 50 and 100 newtons are acting at the same point. So we will have 50 times 0.5, and that gives us the moment as a result of 50 newtons. When we move to sum of anti-clockwise moments, then we'll be able to identify that that will be as a result of the tension in string, or rather rope B. So rope B will cause anti-clockwise turn. Remember, if the tension acts upwards, then the plank would have an anti-clockwise turn. So we simply determine the moment as a result of the tension in rope B, that is tension B. So it acts upwards. We multiply the force, which is the tension in the rope, times the perpendicular distance between the line of action of the force and the pivot. and for this case it is 1.5 meters, and thus we have 1.5 times tension in B. The next thing we work out B, we'll have to divide both sides by 1.5. So for the left hand side we'll have 50 plus 25. 50 is 100 times 0.5 and 25 is 50 times 0.5, and then dividing both sides by 1.5 we'll have that, and therefore this gives us 50 plus 25 is 75. 75 divided by 1.5 gives us 50 newtons, and therefore the tension in rope B is 50 newtons. And that is how we go about this question. I want to thank you for watching. Hope to see you in the next video. Bye.